All right, so lecture 11, characters and strings. We've kind of used strings before. I'm going to create a new project here. Java application, next, and name this lecture 11. Like I said, let's see if I can try to zoom in for you. There we go. We've done strings before. Strings, again, are just words, sentences. They have a set length, but typically you won't reach that length in your code unless you're reading in, full books. But a string name equals Professor Brown. All right, that's a string. String school equals Shaw U. Again, that's a string. And then I could do string, or I could system.out.println name plus space at space school, right? And so what I'm doing is right here, this is a string, I'm concatenating it to this string, concatenating that to school. And I have spaces in here too to make it look good when I print it out. If I hit run, I apologize if the icons are really small up here, it's just the way my computer scaled it. And you should see it down here, Professor Brown at Shaw U, right? Those are strings. Whereas a character is literally one character. So char is how you say it, char, first letter or middle initial equals, and instead of double quotation marks, you do single quotation marks, L, right? And that's a character. So strings are just composed of characters, and that's what we'll talk about today. They're just made of characters. It's just one character after another. A space is a character. And anything inside those double quotes are characters. So before we do that, we're going to look at the math library just so we can cover this and make sure you have a strong understanding of what it is and how to use it. There are several functions available to you. We've used math.pi. Remember, we calculated the circumference of a circle. There's also math.pow. So basically, it's an exponent, x to the power of y, right? So if we go back to NetBeans, I can do int x equals 5, and y equals 5 as well. So system.out.println, actually, let's do result. Int result equals math.pow x y semicolon. Let's see what's going on. So math.pow, I'm guessing, okay, math.pow returns a double. So that's what that error was. So I would do system.out.println x plus x, system.out.println y plus y, and system.out.println results plus results. Before I go any further, I understand today is a lab day. If we do not cover the full slide, or if we don't have enough time at the end of the class to get to the lab, I'll just scrap it for this week since we have the midterm on Monday. But if these slides go a little bit quicker, then we'll do the lab. So if I run this, it should put 5 to the power of 5. Hit run. That is not 5 to the power of 5. Let's see. Why is it 3,125? Should be x to the power of y. And because it's not, this is where good old Google comes in handy. Oh, 5 to the power of 5 is 3,125. I was thinking about 5 squared. There we go. 5 squared is 25. All right, if I do 4 squared, I'll get 16. 8 squared, 64. 9, 81. And then 10 squared, 100. So that's math.pal. It's just a math library or function that's available to you to do some type of equation. All right. Here's some trigonomics or trigonometric functions. We're not really going to use these in this class. I just put them up here for your information. You have your degrees, your 2 radians, sine, cosine, tangent, a sine, a cosine, and a tangent. All right, exponent methods. There's only 2 main ones that we're going to focus on, math.pal and math.square root. Of course, math.pal we just reviewed. Math.square root gets the square root of a number. So we do int x equals 121. If I do math.sqrt x, delete that statement, should give me 11 if I'm not mistaken. Right. So it gives me 11. I can make this whatever number I want, 300. It'll give me the square root of 300. 17.3, whatever it may be. So that's math.square root. That's another function available to you. And those really are the only 2 that we need to focus on in this class. We're not really going to use many of the other ones besides those 2. Not for this class anyway. We do have several rounding methods to round numbers up and down. I gave you the 2 main ones. Of course, math.floor rounds it down. Math.round rounds it as you expect. So if it's less than 0.5, it rounds down. If it's greater than 0.5, or it's 0.5 or greater, it rounds up. Again, I'm just giving you the functions that we'll most likely use in this class. So if I do int x equals 300.58964, this must be a double. Double result equals math.floor. And then I'm going to copy this again. And instead of math.floor, I'm going to do math.round. And we'll see the different results. All right. So you see math.floor rounded it down, and math.round rounded it as we expect. If I make this 0.4896 or 964, then both of them are going to round down, right? So really math.round is what we'll use a lot. Math.floor, you can use that, or another way to convert down, right, is just to convert this into an integer. And then cast math.floor, or actually you don't even have to do that. You can just cast x, and that'll turn it into an integer. And this must be a double result 2, result 2. And that'll give you the same answer for the most part, right? It'll take the decimals off and round down, and then math.round obviously does normal rounding. All right. Math.random does give you a random number between 0 and 1. It's the same thing as random. If we create a random object, so we create a random object, random rand equals new random. And then again, Control Shift I, double x equals rand dot next double. That's the same thing. System dot out dot front line x. That's the same thing as saying x equals math dot random. They're both pseudo random, like I said. There's just another way of doing it. And they're both random numbers. If I run this again, those numbers should be different. Yeah. But they're just random number generators. You can use either one, whichever one suits your boat. Again, the random object, you can do doubles, you can do integers, you can do floats, you can do booleans, whereas math.random only gets a 0 to 1. And of course, if we have a number that we want to get this random in between, we'll do double max equals, let's set our max equal to 100. In order to get a random number between 0 and 100, all you got to do is multiply this by 100. Or actually, instead of 100, because that's a literal, times max. Right? The reason I did times max here is because I only have to change this number one time, setting max equal to 100. If I put a literal 100 here, I have to change that each time. And depending on how big your program is, that could be many, many different lines, and you may miss one. So if I run this, I should get a number between 0 and 100. If I run this a couple times, you'll see that. Now, the likelihood of getting a number between, getting an actual 0 is very, very slim, right? Because this is a double. So it's a range of numbers. It's not the whole numbers, 0, 1, 2, 3, 4. So the likelihood of getting a 0 is very slim. So if I want to get those whole numbers, I can do random.next double times max. And then of course I could do math.floor or round, whichever one. Math.round. And that'll round that number up. Yep, it rounds the number up. Or down. Now I can get a 0, right? All right. So now let's move on to characters. Again, characters are one letter. It could be a letter, it can be a symbol, a number. It doesn't matter as long as it's in between those single quotation marks. So right here, see those single quotation marks? That's a character, right? Note the single quotation marks. Double quotations would make this a string. So if we go back here, char x equals a, string y equals double quotation a, right? And that's the difference between a string and a char. A char can only be one letter. A string can be many, many, many. Right? But it's very helpful later on, we'll see. Because you may want to split stuff at that index. So here are the different methods you can do for a character. Is digit, is letter or digit, right? It's a letter or a number. Is lowercase, is uppercase, or you can capitalize it or lowercase it. So we have our char x, or char x, or whatever you want to say. So system.out.println x. All right, so now I'm going to write a couple different statements. System.out.println is is digit X. Let's see. Again, here's Google comes in handy right here. So we do need import Java .lang character. All right, now I can use that method is digit X. Oh, still can't use that method. I gotta explicitly import it. So you see here, it explicitly imported that method. Another thing I could do, instead of doing that explicit import, I can do a wildcard. So that means I'm importing everything from java.lang.character. That's what the little asterisk does. It should have worked. Import. There we go. So it is a static, and we'll get to that later. That's not important, but it's a static method, so I need that static right there. System.out.println is, what is it? Is letter X. System.out.println is letter or digit X. What else we got? Is lowercase. Is uppercase. So on and so forth. Just so we can know what we're doing. X digit letter or digit. Now I apologize if today's lecture is kind of dry. I mean, it is what it is. It's strings and characters, kind of just for your information lecture. I feel like I should play some music or something. All right, if I run this, we'll get our different results. All right, so X is A, digit is a false, letter is true, letter or digit is true, is lowercase, obviously is false, and is uppercase is true. So that can help you if you're doing if statements or switch statements on a character. You can get if it's an uppercase or lowercase letter or whatever it may be. All right. And then we have our good old strings. Again, strings can be one or more characters, right? Or you can have an empty string. So I can do, I can even have an empty character. I can do that. Oh, apparently I can't do that. But I can have an empty string, string y equals, right? I can establish an empty string, excuse me. So strings can be empty, which is no characters. It can have all kinds of characters in here, and it's still a string. All right. That's important to know that it's an array of characters. That means you can index those characters. So if we have the string welcome to Java, really it's just an array. If you look at that, that's an array. It's basically a list, right? Divided by commas of characters. Right? So we have W, E, C, O, there should be an L right there. O, M, E, space, T, O, space JAVA, right? So it's just index. Here we go. Welcome to Java. And you see each character has its own specific index, 0 through, I can't see, 14, right? And we can index those characters. We can get those characters. So several different methods we have available. One, you can get the overall length of a string, right? So if I have this string, let's say string commentator equals Shannon Sharp, right? All right, so we have oh, that's my commentator wrong? Okay, so we have a string right here. I can print out system or int length equals commentator dot length. And that gets me the overall length of that string. System.out.println length. All right, and that should give me the overall length of this string, which is 14. If I change this from commentator to hello, I do welcome to Java. The commentator, I do hello, hello. That'll give me the overall length of that one, which is 15, right? Another method we have available too is char at, and whatever index we want to get. So if you remember back here, each letter has a specific index, and that goes for any string, right? They're indexed like this, and so you can get the characters at specific indexes. So if we know that T is at index 8, I want to get that T. Right? Somebody spilled the tea. I'm trying to get that T. So char T character equals hello dot char at 8. Right? System dot out dot println T character plus T character. That's my variable. So if I print this out, it gets me that T character right here, right? So we can index that whole string, and the index goes from 0 to string.length minus 1, right? 0 to length minus 1 because although the length of the string is 15, in programming and computing, we always start at 0. So that first index will always be 0. And so from 0 to 14 inclusively are 15 different numbers. 0, 1, 2, 3, 4, 5, all the way to 14. That is 15 total numbers. So although there are 15 characters in this string, the indexes go from length minus 1. Right here, 0 to length minus 1. All right, so if I want to get the last character of this string, well, if I want to get the first and the last, let's do that. Character first equals hello that char at 0. First. And then last is hello that char at, and then I could do hello dot length minus 1. And that'll give me the last one. That'll return 14, right? And the index at 14 is the last character, which is an A, it should be. All right, let's run this. And you see W is the first letter and A is the last. So that's what I did right here. I got the length of the string, and then I did -1 to get that last index. So indexing a string, here we go. Char at 3, char at 7 would be a space, right? And we look down at our array down here, and remember that term, array, because that's what that is. It's an array of characters. If we look at our array, char at 3 is a C, and char at 7 is a space. So that works. We can add strings together like I told you before and like we've done before. So if you look here, we have string A is welcome, string B is to, there's 2 spaces in there as well. String C is Java. If I add all those 3 together, final would equal welcome to Java. And of course we can do our plus equal, right, which additional concatenation to add even more to this string. String A equals welcome, string B equals to, string C equals Java. All right, we have those 3 strings. String final equals A plus B plus C. Let me see. Am I missing? Oh, final is a keyword. Cannot use final. Result. There you go. So here's our string concatenation, right? We have these 3 strings. We concatenate them all together. And we system.out.println result. And it should be welcome to Java. Yep. And then of course we can do result plus equal time to do some work. And that adds to that string, system.out.println results again. And that string should have that additional characters. So the first thing we print was welcome to Java. And then we added to it, result plus equal time to do some work. And you see that down here. Okay? And then again, we can get the final or the last character by using the length -1 method. So char last equals result dot char at. And then how do we do this again? We first get the length of result -1. And then we system.out.println last plus the variable last. And I can print all of that out. The last one is an exclamation point. All right. Comparing strings, so we can compare them. We have string 1 dot equals string 2, so you can't do the equals equals, which is for like numbers. So if I have these 2 numbers and I want to compare them and see if they're equal, I'll have int x equals 10 and y equals 11. If x equals y, print, not print, system.out.println equals. Else, this means they do not equal each other. System.out.println not equal. And so those 2 numbers are obviously not equal to each other, so it should print out not equal. All right. However, we cannot do the same thing for strings. We can't have this string x equals Michael Jordan, string y equals Kobe Bryant. We can do x equals y. However, it doesn't compare the way we think it does, right? The way it looks like it would. It's really comparing, I believe, the data types of them or the size of them. I can't remember exactly what it's comparing, but it's not checking if the strings are equal to one another. It's checking something else. So in order to check if the strings are actually equal to each other, instead of equals equals, we would do dot equals y. All right, and that'll check them as we expect. Then you have equals, ignore case. So if I have this right here, and I have this, right, these do not equal each other, not equal. But if I have equals, equals, ignore case, and these should be equal to each other. There you go. We have compare to, so if we want to see which number is, if we're trying to sort these alphabetically, we would use compare to, and if the number is negative, that means whatever the first string that we're comparing is goes before the second one. So for example, I think capital M's go after lowercase m's. So if I do system.out.println x dot compare to y, right? It should spit out a positive 1 or a negative 32. Was not expecting that. But I think capitals go before lowercase if this is to be read correctly. And the number 0 means they're equal. Anything negative means it goes before. Anything positive means it goes after. Okay. So if I do y dot compare to x, it should be a positive number. Yep. So that means y goes after x. I can also do, to make this a little bit clearer, first S1 and S2. All right. I can also do S1 dot compare to ignore case, which ignores the case, and it should be a 0. Yep, because they're equal to each other. We have starts with, so if you want to check if it starts with an MIC, you would just do if, actually, S1 that starts with string 2, that's true. All right, it starts with the same numbers, or same letters. It would not work in the inverse, so S2 does not start with Michael. Although the first couple letters are the same, S2 is just MIC, and it's comparing the entire string. So it doesn't start with Michael. We have ends with, which is pretty much the same concept. Contains, so if this is CH, I want to check if that contains CH. So S1 dot contains S2. And of course, there are many other methods available to you, but these are just a few. If this is CHL, the way contains works, it's literally how those letters are imported or written into S2. So although Michael contains these 3 characters, it doesn't contain that string, right? That whole string. We have substrings, so if I have welcome to Java up here, and say, for example, I want to just get a substring of that, just a small piece. I just want to get the 2 right here, right? Well, one, you need to know the index, right? And we know just from previous examples, the index is 8 and 9. But we have to put in 10 because it stops at the end minus 1. So 10, index 10 will not be included. It'll be index 8 and 9, right? So if I show you this running S1 dot substring, there are two of them. If I have if I use this method, it's just gonna get the first index and then the rest of the string. But I want an actual substring, 8 and 10. I hit run, it spits out 2. All right. And there is one other method I want to show you. It's called split. And you can split strings based on certain characters. So for example, and it splits it into, actually, we'll cover that later when we talk about arrays. But for right now, these are the main methods for strings and characters that you should know. Any questions about characters and strings? All right, if not,